Now, scientists believe that there are new opportunities to develop a cure for HIV/AIDS. It follows a promising study of 9 women which found that the HIV virus went into a hidden state in their bodies to evade treatment. While researchers have hailed the latest development, it is as a step in the right direction. They argue the path to a cure is long and quite complicated. Well, let's discuss this further. I'm joined by Durban Professor Salim Abdul Karim, who is the Director of CAPRISA. Thank you so much for your time tonight, Professor. You've long maintained that developing a cure for HIV/AIDS is certainly something that is going to take a long time. What then is the significance of these little milestones that you almost keep reaching in the form of the research that you're doing that leads you to believe that there is something groundbreaking taking place?
Yeah, good evening, Kathy, and good evening to all of the viewers. When we take antiretroviral treatment, we know that we have to have this treatment for our entire lives. So anyone who has HIV, if they don't take their treatment, even briefly, then what happens is that the virus comes back. So where is this virus? Where does it come back from? Well, we know that it comes back from viruses that are deeply hidden in what we call the viral reservoir. And this viral reservoir is in deep tissues. Now, until now, we thought that when you acquire HIV infection, the viral reservoir is filled with viruses, and so there's nothing we can do about it. Now, this new study, which was published in Science Translational Medicine, a study done by a team that involved researchers at the University of Cape Town, CAPRISA here in KwaZulu-Natal, and the University of North Carolina in Chapel Hill. This group came together to study these 9 women, and what they learned is that most of the viruses, 71% of the viruses that are in the reservoir, go into the reservoir when you initiate antiretroviral treatment. So what does that mean? That means that the biggest obstacle to a cure, the viral reservoir, that if we can intervene at the time of initiating ART, we can prevent those viruses from entering the reservoir and create then only a small reservoir would be much more easily curable than having a very large reservoir from viruses at the time of treatment. So that's what this means. It turns our thinking on its head about how we might approach a cure. It's not a cure. We don't have a cure. There is no cure in sight, but this gives us one step towards a cure.
When you talk about then having that important signal, as it were, around where and how intervention can take place when people are starting their treatment, does that include the development of different kind of medicines that you would now have to add to those that people are, to that treatment that people are already taking?
Yeah, so there are many different possibilities. We ourselves are looking at the possibility of using an antibody. Now, we have discovered a very powerful antibody from a woman here in KwaZulu-Natal, and we think that this antibody may bind the viruses, and when it binds the viruses, they won't be able to go into the reservoir. So at the time of initiating antiretroviral treatment, putting patients on an antibody may help. But an antibody is not the only option. We have several other ways in which we might be able to intervene. And it would mean that patients either take some additional form of treatment or go on to a course as they initiate antiretroviral treatment that would help prevent those viruses from entering the reservoir and enabling us to create a situation where you have only a small reservoir available.
The studies that you're talking about and that you've conducted certainly do not take a short amount of time. You're looking at sometimes around a decade or just over a decade of patients with whom you've been treating and have had to study the different responses that their bodies have to the treatment and to the virus. What does that do for the research process?
Well, you know, in what we are doing, nothing is done quickly. Good science takes a lot of time. So we're not looking at, overnight solutions. This particular study that I am quoting the results of is a study we started in 2003. So that means that we have now been following these women up for over 15 years in some instances. And that's what it takes. That's what it takes in order to be able to do the kinds of research that we are trying to do. Because it's very complicated to actually do the individual sequencing of viruses and then to determine which viruses entered the reservoir very early in infection and which entered more recently has to be a very complex process of determining probabilities of the different viruses and the way in which their sequences are similar to others at different times. So we take it year after year and we say, okay, the viruses in year 1, this is what they look like, the viruses in year 2. So do we have viruses in the reservoir that are similar to year 1, to year 2, to year 3? And what we discovered is that most of these viruses are actually similar to the last viruses we detected prior to treatment. And that's what this breakthrough is about.
South Africa carrying the global burden, as it were, of HIV/AIDS, what does that do for institutions like yourself and the partners that you've been collaborating with to conduct multiple research projects into the HIV virus? Does that make South Africa, almost at the frontiers, on the front line of the research that is being conducted?
Well, there's no question. I mean, in the whole world today, as we speak, there are about 38 million people living with HIV. And about 1 in every 5 people living with HIV lives here in South Africa. So in many ways, we have to show leadership. We have to be taking the lead in solving this crisis. So if we look at the HIV epidemic, about 5,000 new cases of HIV occur each day. Now, when we look at those kinds of numbers, we have some idea of the enormity of the challenge. HIV is a global problem of enormous magnitude. So when we try to find prevention solutions, when we try to find vaccines, or we try to find and do research on a cure, it's all part and parcel of ensuring that this problem is something that we can tackle right here in South Africa. The fact is that anything we develop for South Africa is also something that will be globally relevant and globally helpful. And so that's why the research that we focus on here has such global implications and could impact the HIV epidemic in the whole world.
And to the extent that our infection rate remains quite high, especially when you look at some of those figures that you've just given us, I mean, does that mean that the approaches that we've been taking are not as effective as they should be, really?
Yeah, so we've understood that, in the last 5 years, we have made little impact on the number of new infections each year. In fact, it has remained pretty static. And so that's why when we look at the problem of HIV and that it's not getting better, so researchers like our group have come together. So we had, for example, Professor Carolyn Williamson and Dr. Melissa Rose Abrams from Cape Town. We had Professor Ron Swanstrom from the US. We had Dr. Nigel Garrett and myself from Durban. When we sat around the table and we said, this is the problem, how can we make a contribution to ameliorating this problem? How can we find ways to help make this less of a problem. And so that's how we've been putting our minds together and trying to find solutions and coming up with solutions. And I think you're right, that in many ways, if we sat back and said, well, we'll wait for the rest of the world to solve the problem, we will be judged harshly by history. HIV is a huge problem in South Africa. We have the biggest HIV epidemic in the world. It's our responsibility to rise to that challenge and to do what we can to solve this problem right here in South Africa.
Professor Salim Abdul Karim, thank you so much for your time tonight on News at Prime. He is Director of CAPRISA. I'm back in a moment